Okay, this is continuing on from the introductory video to the endocrine system, and I'm going to call this video number 1 for the endocrine system. So here are the learning objectives for video number 1. First of all, be able to describe the 2 general categories of hormones. The second learning objective is to describe the solubility of these 2 general categories of hormones. And number 3, to identify the location of hormone receptors, where those receptors are located, and what happens if a cell doesn't have a receptor. So this is what we want to accomplish. By the end of this video, you should be able to answer these 3 questions. So first off, I actually want to talk about solubility because that's going to help us get into the general categories. A general theme throughout all of physiology is solubility. And I would tell you that if this slide here makes no sense to you whatsoever, then you really need to go back and cover this material again. So generally speaking, we think of things as being either water soluble or lipid soluble. It's going to be one or the other. It's going to be water soluble or lipid soluble. Now, look, in real life, it's a gradient, so there's shades of gray in between. There's things that are super duper water soluble, a little less water soluble, a little bit less water soluble, and super lipid soluble, etc. But to keep life simple, what we generally do in physiology, at least at this level, is to simply describe things as being soluble in water or soluble in lipids. And so another way of saying this is that we have things that are hydrophilic and we have things that are hydrophobic. So then the question emerges, what makes something water soluble versus what makes something lipid soluble? So again, this is some of the stuff that I don't want to get into because you should have covered this in an introductory bio course or in the first semester of anatomy and physiology. All I'll say here is that things that are water soluble are polar, and things that are non-water soluble are non-polar. They're generally made up of non-polar covalent bonds, whereas these are either ionic or they're made up of polar covalent bonds or something to that effect. So the point is charged versus uncharged. So again, I'm just going to repeat myself and say this idea of solubility is absolutely critical. I can't emphasize it enough. It is a core principle of physiology. It's the equivalent of saying, if you're going to play basketball, then you have to know what it means to dribble. Like, well, dribble? What is that? And so you can't say that. You got to know what it means to dribble. You got to know what it means to shoot. If your coach says shoot, then you should know what that means. Same thing here. In physiology, solubility is an absolutely core principle, so make sure you get this. So just to rehash though, if we look at the big biomolecules, when we look at carbohydrates and lipids and proteins, remember that these are 3 of the big 4. Nucleic acids are also in there, but I'm not including here in this review. So the big 3 biomolecules are carbohydrates, and here are some examples of those. Lipids, here are some examples of lipids with a kind of special mark next to phospholipids, and here's the building blocks of proteins and our amino acids. So generally speaking, carbohydrates are water soluble. Generally speaking, lipids are, as the name would suggest, they are lipid soluble. Generally speaking, proteins are water soluble. There are some exceptions, but as a general rule of thumb, to say it differently, then we would say something like this. These are generally speaking hydrophilic, then these generally speaking are going to be hydrophobic, and then these guys down here, proteins in general, are going to be hydrophilic. So again, I'm not going to go over the properties of individual biomolecules, but if you need to, go back and do those. So now, with that covered, now we can get into the first learning objectives. Describe the 2 general categories of hormones, and what will follow from that is the solubility of those 2 general categories. And so the 2 general types or categories of hormones are those that are amino acid based and then those that are steroid based. And so amino acid based hormones and steroid based hormones. Some texts will tell you that there's 3 types of hormones. There's amino acid based, then peptide based, and then steroid based. And we're just going to simplify it to kind of keep it simple, stupid, that whole mantra. And so we're going to say there's amino acid based, which would include peptides, and then there's steroid based. And so, well, if you look at that, amino acid, where did we see those words? We just saw that because amino acids are the building blocks of proteins. And remember, peptides are short strings of amino acids. And so what do you think here? These types of hormones that are based off amino acids, are they soluble in water or soluble in lipids? Pause the video, take a stab at it. And hopefully what you're doing is putting 2 and 2 together here. I strongly encourage you to always make things make sense. Always try to put 2 and 2 together. Don't just wait for me to give you an answer and try to memorize it. Make it make sense. So, well, if you know proteins are made up of amino acids, and I told you that they're water soluble and hydrophilic, then generally speaking, amino acid-based hormones will be water soluble. Okay, so that answers this question. Describe the 2 general categories. One is amino acid-based, and it is water soluble. Well, what about these guys, steroids? When you look at steroids, you can actually see some of these: estrogen, testosterone, progesterone. These are all hormones that you probably heard of before. Aldosterone, maybe, maybe not. Cortisol, maybe, maybe not. These are all derived from cholesterol, and they form these family of hormones referred to as steroid hormones. So cholesterol, what do you know about cholesterol? Again, even if you can't kind of figure out what these symbols mean, you know, what these weird like six-sided structures mean, that's not important right now. But what do you know about cholesterol? Well, what you probably remember from cholesterol is that cholesterol, right over here, is a famous lipid, and that's why I wanted to do this quick review here. Cholesterol is a lipid. Cholesterol, it doesn't like floating around in water. It's lipid soluble. It is hydrophobic. It does not like water. And so these steroid-based hormones, then, what do you think? Describe the solubility. Are they going to be water soluble or lipid soluble? Well, they're going to be lipid soluble. So now we've knocked out these two learning objectives. Describe the two general categories of hormones: amino acid-based and steroid-based. Describe the solubility of these guys. Well, the solubility is that amino acid-based hormones are, what are they? They are water soluble. And then the steroid hormones then down below, what are they going to be? They're going to be lipid soluble. Now, pause for just a second. Before I move forward and before I throw more information at you guys, pause for just a second and ask yourself the question, why do I care about this? Who cares? Why am I just memorizing this kind of trivia about amino acid versus steroid-based hormones? Well, let's look at this. Let me go back here. Let's take estrogen. Estrogen is a, what, amino acid or steroid-based hormone? Clearly, it is a steroid-based hormone. It's derived from cholesterol. So therefore, estrogen is water-soluble or not? And the answer you should be coming up with right now is no, it is not water-soluble. It is not water-soluble. Remember, we just answered those questions. We talked about the solubility stuff. So we just addressed the question, and should make sense to you now that, look, cholesterol is not water-soluble. Therefore, estrogen will not be very water-soluble. So now, let's go back to what we talked about in the introductory video. In the introductory video, what did I say? I said, well, let's call this little triangle estrogen now. You've got an endocrine cell in the ovaries, ladies. And so the ovaries produce estrogen. And so estrogen is going to go out and it's going to go into the blood. And that from the blood, that's how it gets from point A to point B, which is going to be, let's call it brain tissue. Let's say this is your brain, because your brain has tons of estrogen receptors. So these are receptors to estrogen. They receive the estrogen, and now the brain says, yay, I love it. Now I can work the way I'm supposed to work. So how did estrogen get from point A to point B? And the answer is through the blood. Now, ask yourself the question, what is your blood made of? I know we haven't covered blood yet, but if I just had to ask you, look, is it primarily water or is it primarily oil, lipid? You would probably say water, because somewhere along the way, even before you started A&P, you probably heard some factoid that said 90 whatever % of us is made up of water. So you know that there's water all over the place. So to say it differently, your blood is made primarily of water. But hang on a second. Estrogen is derived from cholesterol, and it is hydrophobic. It hates being in that water. So how is it possibly going to make its way from point A to point B? Why would it not just cling to the walls of this blood vessel like cholesterol does, and thereby causing heart attacks and things like that? What is going to make estrogen be willing to move along this this watery passageway that we call our blood? And so there is an answer to that, and the answer is, well, actually, before I give you the answer, what I'm trying to get at here is I need you to realize, like, yeah, man, that's a problem. That's a problem if, I'm going to go back to that slide. Sorry to hop around here. It's a problem if this is a steroid and it hates water, and yet all of this stuff is water. How does it get there? And here's your answer. It needs a boat. Look, you and I probably both know people that can't swim worth a lick, but yet they're willing to hop in a boat and take a cruise. They're willing to hop in a boat and ride around, Burke Lake or something like that. And so what do? They hop on a boat. Now here in this picture, there is no boat, but what that tells you is that somewhere along the way, see that thing I just inserted there? That is a boat. That is a protein, and estrogen will hook up with that protein, and therefore he's protected from the water and free to go from point A to point B. So that becomes very, very meaningful. To say it differently, look, some hormones have an easy time going through the water, like amino acid-based hormones. Other hormones, they depend on yet another prerequisite, which would be the presence of boats. So that should send you down a road, and that should say, okay, fine, what are these boats? Where are they coming from? Well, I told you what they are, they're proteins. Where are they coming from? Yeah, we don't need to know that right now, but when in doubt, for the rest of physiology, if you don't know where a protein is made and you have no clue and it's a random guess, just say liver. And in this case, you'd be right. It's called sex hormone binding globulin. It's produced by the liver, and it's estrogen needs that to get from point A to point B. Now, again, pause the video just for a second and think about, just chew on this. Who cares? Is this just more trivia or not? Okay, hopefully you thought about it a little bit, and here's what you should come back with. You may or may not have. I'm just going to assume you didn't, so here's what I want you to think about. Ready? True or false? Women can experience symptoms of estrogen deficiency. And your answer probably should be, yeah, maybe you have a girlfriend that's experienced symptoms of estrogen deficiency. And let's get away, let's talk premenopausal. Okay, I don't want to talk about perimenopausal and menopausal women. Let's go in your 20s, let's say, is it possible to have symptoms of estrogen deficiency? And the answer is yes. So then the question becomes here's the question. Is your problem an ovary that is not producing estrogen, and therefore your brain tissue is not getting estrogen? Is that your problem? Or is your problem a super healthy ovary, but not enough boats? The liver, for some reason, is not producing enough boats, so therefore, even though you got tons and tons and buckets of estrogen piling up in the ovaries, they have no way to get from point A to point B because there are no boats. You can see that they're completely different issues. One issue is an ovarian issue. Another one is a liver issue. One is you don't make enough estrogen, so just go ahead and take some estrogen. The other one is like, dude, I got plenty of estrogen. I just can't transport it from point A to point B. It's almost like if you've ever had a package that Amazon has shipped out, but it's stuck like in Tennessee or something, if you track the packages. And you're like, man, I know Amazon did its job. It shipped this thing out, but like it's just stuck in Tennessee and it's just not getting on its way to wherever your destination might be. And so the problem is not production of the thing that you ordered. The problem is not in shipping it out. The problem ultimately is getting it to where it needs to go, the transportation, getting it there. So that's why a lot of the stuff becomes very, very relevant. Okay, so now I think, let's see, I'm going to try to keep these videos a little bit on the shorter end just to make them digestible. And so I'm going to cut this video here and I'm going to rework this slide. And so this will go on, this identify location, hormone receptors, etc. will go on to a separate slide deck, separate video. So now, just to recap then, ignoring this thing right over here, let's ignore that. So what do? We describe the two general categories of hormones, and we describe the solubility of those categories. We have amine-based hormones, amino acid-based hormones, and steroid-based hormones. Amino acid-based hormones are water-soluble, steroid-based hormones are lipid-soluble. To say it differently, amino acid-based hormones are hydrophilic, and steroid-based hormones are hydrophobic. And that'll wrap up this video.